Hello, everybody. Thank you, everyone, for joining us. This is BrainX Community Live, December 2025 event. This is our last event of the year, and it has been an exceptional year. There's so much research and development work that has gone around AI in healthcare this year. And we started this year uh, trying to address the issue of how do we evaluate LLM applications in healthcare. There's so much research work going on, so much development work going on, but we were still trying to learn about how we can evaluate LLM applications in healthcare. And I'm so excited that there has been so much work done throughout this year, and we are going to be featuring Suhana Bedi and Raghav Awasthi, trying to summarize some of the work, some of the exceptional work that has been there, so that we can all learn from the development that has happened over this year, and thereby hopefully focus next year on building robust tools which lead to sustainable change and impact in healthcare. So I always believe with my heart in quality that we need to start with ensuring that we are evaluating things, measuring things the right way, and that was a key focus this year. So a lot of new people who have joined today. We'll be recording this event. It will be available through our YouTube channel and through our website, which has the link to our YouTube channel. So please subscribe us over there. But to talk about BrainX community, we started this community uh, as a machine learning and healthcare for good community where we wanted to foster collaboration, enrich everybody's knowledge related to all the advancements in this space. We have had 7+ very successful years. The community itself has grown to be 7,000 plus member international community. We have a very active LinkedIn group with more than 3,600 members now. And we have our website, which serves a repository of a lot of knowledge and information that I'll share with you shortly too. And then we do these live sessions where we share the research and development work of many of the leaders, many of the researchers from across the world related to AI and healthcare. So please try to join us every for these sessions. This is our website. You'll find the latest updates right on our webpage. It's brainxai.org. There is a subscription area over there too. You can subscribe to it. You'll get our newsletter on a monthly basis with the latest updates. We have the Connect segment where we feature upcoming webinars like these ones, and we also post the ones that have occurred, the links to our YouTube channel. And through the YouTube channel, you can watch the prior events recordings. And I believe there are like more than 70, 80 of these now. So whichever ones are of your interest, you can go ahead and watch them even if you missed the live event. As I mentioned, we have a very active LinkedIn group. So a lot of knowledge is shared through this social media platform, including latest publications, upcoming conferences, and other material. We also feature some of the key publications that you might want to know about because there's so much getting published, so much getting research in the AI and healthcare space. So we provide links to some of the key publications. They are categorized based on healthcare specialty. So there's a filter option, and you can find different publications of your interest right through the Learn section of BrainX Community. Everybody is looking for data. So we provide the largest repository of links to open source data sets. We can't provide data directly, but these are open source data sets that are available to foster your research, to enable you to build interesting models or validate interesting work that you might have done. Again, these are categorized by different healthcare specialties or topics, including LLM and generative AI. So you could filter for these data sets and find the one that you need to help you get started. We also have our podcast series through different podcast medium, and in 2026, I'm very excited. We're gonna reintroduce it with some of the leading figures who are working in AI and healthcare space. So watch out for that. Key conferences, they are listed on our webpage. So you could look at where you want to go, where you want to present your work, where you want to connect so that you can foster collaborations too in the future. a couple of books that came out this year, again through collaboration of many on BrainX Community, and might be helpful and interesting read for you. But importantly, this December event, we are once again bringing Suhana, who we had featured at the beginning of the year. She has done some exceptional work in looking at how to evaluate the LLMs, specifically in healthcare. And I learned a lot from her research work. It's truly amazing and exceptional. And then Raghav, who is our team lead for BrainX AI research. We have been working on quite a few different research areas and also trying to develop certain tools that everybody can use. Is going to talk about that too. So with that, I'm going to welcome Suhana Bedi from Stanford University to have her presentation. Welcome back, Suhana. So excited to have you back here.
Thank you. Thank you for inviting me. Awesome. Let me share my screen and we can get started. Awesome. All right. So you should see my screen right now. If you don't, feel free to interrupt me at any point. Hi, everybody. I'm Suhana Bedi. I'm a third-year PhD student at Stanford working with Nigam Shah on questions around evaluations of Gen AI in healthcare. So today I'll be focusing on two key papers that we published last year or this year and just some of the learnings from them and where the field is headed. So actually, last year, Piyush was kind enough to invite me at the BrainX session, and I talked about this one paper from 2024 on AI evaluation. So what we just a quick recap there, we had evaluated 519 studies that explicitly evaluate LLMs in healthcare, and this was taken from 2023 to February of 2024. And then we saw that most of them were focusing on medical exam questions, and very, very few of them were using real patient data. Of course, things have evolved. We're seeing more and more papers that are moving beyond multiple choice questions and that are moving to evaluating models on real patient data. But why is that important? So, as you can see here, on the right is a real clinical note with a lot of um, jargon and shorthand, and I'm sure it varies from clinician to clinician. And then on the right, we see medical exam questions, which is MedQA, the USMLE board exam that usually residents or med students take. And initially, the field was headed towards, oh, if a model can solve or get a good score on the MedQA, it's ready for the clinic. But as you can see, real EHR data is very different from clean exam questions. And medicine is not a multiple choice question. I've talked to a bunch of clinicians around this, and we've often laughed thinking, a clinician never walks into the office and they're never presented with four options and asked, okay, what does this new patient that you're seeing today has? They have to come up with everything, differential diagnoses, collecting all of the patient information, ordering labs. It's a whole workflow that a clinician does, and it can't be oversimplified by medical exam questions. And another important thing being, these questions don't really cover all of healthcare. So we're focusing mainly on clinical decision support. Now with AI scribes, of course, there's a part on scribes, patient communication, and what we're missing here is the administration piece. So a lot of the healthcare workers are overburdened because of all the billing codes, all the revenue cycle management pieces that exist that are sort of nested away from these exam questions that we see. So to sort of answer all of these questions, we came up with MedHelp. So it is actually it's a one big term for a lot of moving pieces. So let's go over that together. So MedHelm is a combination of a task categorization or a task taxonomy of what do people in healthcare do. And we'll go over the taxonomy in a bit, but this was the first piece of information that we needed to sort of build the next MedQA, build the next test for LLMs in healthcare by really understanding what are the workflows that clinicians are doing. Again, it's not going to the office and having to answer a question with four clear options. It's much more difficult, it's much more concrete, and it's much more open-ended. So that was our first step. Second was we mapped benchmark data sets to all of these tasks. So we wanted to first see, are there publicly available data sets that can be repurposed to represent a certain medical task? If not, we created a data set of our own to get maximum coverage. And then third was coming up with evaluation metrics. So we have a combination of open-ended and close-ended questions. What do those mean? Close-ended, again, multiple choice or one-word answers. Open-ended is when you are summarizing a note. How do you know a summary is good enough? Or you're doing a free text Q&A session. How do you know those answers given out by your model are okay? They are not, they don't have hallucinations, they don't have inaccuracies. So we come up with metrics to capture that. And then we're basically running 9 state-of-the-art models, and we have released a leaderboard. We have released our taxonomy. We have released the mapping. And we really hope that this turns into a community living and breathing resource where everyone is pushing more data sets, more models as we're stress testing Gen AI in healthcare. So this is the taxonomy that we created actually with 30 clinicians across different hospitals, Stanford, Mayo. And the main purpose again here was to capture the breadth of tasks that the healthcare system does. Of course, like here we have, 5 categories, 22 subcategories, and 121 tasks, but it's way broader than this. This was our first stab at it by talking to all the clinicians and what they think are tasks they do on an everyday basis. So we're hoping and expanding on this taxonomy. Again, if folks have suggestions, the taxonomy is open source, available. If we're missing tasks, let us know. So once we zeroed in the task taxonomy, next step was mapping the data sets, right? Now, as I mentioned, we have 5 categories, 22 subcategories, and 121 tasks. So we tried to get coverage, full coverage, across all the subcategories and categories, because as you might imagine, 121 tasks that might entail 121 data sets. Our team wasn't as big. We didn't have that many resources, but we wanted to start with at least getting some coverage. So we first started with existing data sets and saw, okay, how many of them can be repurposed to answer some of these categories and to fit the definitions. Then we, of course, still had some subcategories that weren't fulfilled. So then we reformulated 5 benchmarks. What does reformulation mean? The data set was out there. It wasn't converted into a benchmark. And the difference between a data set and a benchmark is basically a benchmark constitutes an input, an output, and a way to evaluate the output. So we reformulated those. And then for when we absolutely had no data set available, we created our own data sets. 12 of these actually contain real patient data, actual patient EHR. And surprise, surprise, most of them are from the administration category because none of this data is publicly released. So then we wanted to select models. Again, back in the day, I'm saying back in the day as if it was like years ago, but the field moves so fast. But when we started this project, DeepSeek R1 had just come out, and OpenAI had just released O3 Mini. So those were the two models we chose for reasoning. Then we chose some general open source models, and we chose sorry, we chose some general proprietary models, and then we chose one open source model, which was Llama. And as I mentioned, the pipeline is very simple. We're taking the 37 benchmarks covering our 22 subcategories. And again, some of them are close-ended, some of them are open-ended. For open-ended, we are basically developing a rubric for each of the data sets, and we're actually using a jury. So the concept of LLM as a judge is getting really famous, but of course it comes with its own biases. And it's said that if you average across a bunch of judges, you are sort of regressing towards the mean. You're getting rid of those averages, of those biases. So we took 3 LLM judges that constitutes a jury to evaluate the output of our open-ended tasks, and then we basically analyze our results. So here are the overall rankings. So win rate, again, is a very common metric in a lot of leaderboards, Helm, LLM Arena, that's often reported. And it's just basically the proportion of pairwise comparisons, say between model A and model B, and how many of those, say, model A wins at. So we're seeing that DeepSeek R1 and O3 Mini are sort of our top performers. We label DeepSeek R1 as top because the standard deviation is lower. But again, like in the paper we mentioned, they're both pretty much equivalent, followed by some of these Claude models. 3.7, we're using the non-reasoning version. So we're seeing quite a difference in reasoning model capabilities versus non-reasoning models. And unfortunately, Llama 3.3, the open source models are still catching up or trying to play catch up. We also ran these experiments on MedGemma, a Quen model. They're all in the appendix, but the performance numbers were really bad, which again shows that we as a community maybe need to work more towards open source models. Performance by category. So this was really interesting and actually pretty intuitive. So you can see how admin and workflow suffers the most. It is the worst performing category. Why is that? Most of our data was created in-house using patient EHR at Stanford. And these models have not been trained on EHR as far as we speculate. Or these are tasks that the models haven't been trained on. So when they're tested with it, they really collapse, which is interesting also because we're seeing this trend of startups, especially in the Bay Area, moving towards administration and workflow tasks because that's where a lot of the burden lies. But if you're just using off-the-shelf models, you probably can't squeeze out a lot of good performance, and maybe you have to rely on more post-training to make your model better. And of course, across clinical decision support, medical research assistance, we see similar trends, not as severe as admin and workflow. Clinical node generation, patient communication, that's where all the patient scribe work, AI scribe work lies, AI chatbots lies. So those seem to be doing pretty well. So this is great, right? We did this deep dive into models that are evaluated across a breadth of tasks that we hope encompass healthcare. And we're seeing these interesting trends where, administration is not as good. Still, it's not horrible. Like, of course, there's some promise there. Um, but the one question that we should all be asking is, how are these models working? Are they getting the answer right because they understand clinical decision support? They understand what is a discharge note. They understand all of these concepts. Or are they just exploiting answer patterns they learn from training data? And again, we know all of these models, standard transformers, next token prediction, trained on massive, massive amounts of data. So are they just doing that statistical next token prediction based on the trends they've learned? And would they act up if we were to change the data they're supposed to answer questions on? So we did a very simple test, and this came out in JAMA Network Open. We took MedQA, one of the most overfitted benchmarks, and what we did was we replaced the correct answer for our MedQA questions with none of the above, or none of the answers. And the test was very simple because we wanted to see, oh, can the model now still perform as good as it can? Because we have taken out the clear answer that probably it was trained on, since MedQA is open source. And we replaced it with none of the answers. And we had a clinician manually verify whether, if we do this substitution, the question, none of the answers is still the correct answer. So we had a clinician go through those. And we see performance drops. So this was across 68 MedQA questions. Again, small sample size. We were limited by clinician annotation there. But you can see how there is a good performance decline on this NOTA modified questions. And for some, again, Llama, the open source model, it's like a 40%, 50% decline. Reasoning models, sure, they do well, but this is still a non-significant amount of decline. Again, these were all statistically significant, so I didn't even put asterisks to indicate that because it's so clear. So surprising, but probably not surprising, right? Because we're doing this robustness check on models and seeing whether they break when we change the input that they've usually seen. So what's the conclusion here? Again, yes, it's very important to evaluate, as Piyush was saying earlier, especially in a high stakes setting like healthcare. But we are all for innovation. We want to embrace technology. We want to improve patient care. We want to improve clinicians' experience. So what is the path forward? Capability is not equal to robustness. So we saw that through MedHelm, models can perform many medical tasks. They're not perfect, but hey, they're pretty good. But that does not imply that they would not break under unfamiliar data, small changes, or domain shifts. So what is next? Where is the field heading? Do we keep creating more benchmarks? Do we keep stress testing models? 100%. But the field is moving really fast. So now people are pivoting towards live testing. One of the first instantiations of a live test was actually done at ChatEHR, which is a instance within Epic that was incorporated by the data science team at Stanford Hospital. And it's a language model that's attached to all the EHR data, and doctors are querying it and using it. So that's a live test. And the doctors are very well aware that the model can have hallucinations. The model can probably break under distribution shifts. But hey, again, some of them are having a great time. Some of them probably are not having a great time, but they're giving us continuous feedback. We're collecting this feedback data through the live test to understand what are the gaps when we just throw these models in a real world setting, and where we're seeing impact and where we're not. And we have a lot of success stories at Stanford itself. We're hoping to release a paper soon. So this is what we as a field, we as a community need to think more about. Let's get into live testing. Let's get our hands dirty. Yes, we will see some very interesting trends. Yes, we will see some very interesting failure modes, but we will also see some great impact. And we need to make sure that experiencing these failure modes or stress testing these models sort of gives us an idea of how to build the next generation of models, the next set of architectures. Um, because hey, Gen AI, again, a lot of people say it's a phase, it's going to be replaced by world models or something. But something that's always going to be impactful, needed, is evaluation. No matter what model you're using, no matter what method you're using, evaluating it and stress testing it correctly is always going to stay relevant and important for the field to progress. So in the audience, all researchers, all doctors, all technologists. This is a very exciting time. And I think true innovation and true development lies if all of us work together on shaping not just models, but also how we're evaluating and stress testing them. Thank you.
Well, that was awesome, Suhana, and always amazing to see how much work you have done in just 1 year. Not that it wasn't there, you didn't do that prior to that, but just this 1 year, if you think about the amount of work that has gone into it. Love the reasoning paper that you had out there. In the link for the audience, I've put in the links to Suhana's papers that she was referencing in there, so you can click on those. And as I get invite Raghav uh, to share the screen and make his presentation, please put in any comments or questions in the chat. So we'll be taking those at the end. Uh, we, to me, there are still a lot of questions that we need to resolve. And I agree that the real test is when you put something in real life, because we can do as much bench or lab testing of these models till the time we don't do usability, feasibility studies, and till the time we don't see and understand the real life gaps. It's a completely different ball game compared to testing them on some prior data sets. And you're right, we'll unearth so many different issues probably that we have not even thought of right now. So awesome work. And I have a few questions already for you, Suhana, at the end. So Raghav, we'll invite you to make your presentation.
Sure. Let me share my screen first. Is my screen visible?
Yes.
Okay. Hi, everyone, and thank you, Dr. Mathu, for inviting me. So I'm Raghav, and currently I'm a postdoc at Case Western Reserve University, and also I'm leading the BrainXAI research. So today I will be talking about the tools we have built for doing the human evaluation, and I will discuss some of the the scalable and human in the loop approaches. So let's start with the motivation. So we all know since the launch of the chat GPT and since the more models are LLMs models are coming, so there is a lot of research going around the evaluation, but still uh, the human evaluation is considered to be a gold standard. But the thing with human evaluation is that there is a lack of standard framework, and also human evaluation is very time consuming. So how can we scale the human evaluation? So I will be our lab has developed some of the tools for doing the human evaluation and also the scaling the human evaluation. So I will be talking about these two tools. So, let's start with some of the systematic reviews we have done. So we were studies 186 research papers from the January 1st to January 1st, 2020 to July 19, 2024, and just try to understand like what kind of matrices people are using for doing the human evaluation. And we found a very interesting patterns out there. So out of these 17 matrices, accuracy was like used for all of the studies. But if you see the harm related matrices like bias, toxicity, privacy, and hallucination, they were used on the less than 10% of studies. This make us little bit worried. So we thought that because these are the very important matrices to measure out of LLMs, but they were not very frequently used in the researches. So we try to build a framework where we can present the exhausted set of matrices, and where uh, people can easily and interactively do the human evaluation. So first, we have proposed some few set of matrices broadly categorized into the relevance, coherence, comparison, coverage, and harm. And then within all these big matrices, we have also set some of the sub matrices. For example, for the relevance, we have a sub matrices like accuracy, comprehension, reasoning, and helpfulness. And for the coherence, we have a some matrices like fluency, grammar, and organization. And for the harm, we have a matrices bias, privacy, hallucination, and toxicity. And for the coverage, we have matrices like topics, content, and missingness. And for the comparison, we have a matrices formatting, human like, and the alternate LLMs. So these 17 matrices make the set of human evaluation is exhaustive, and these all matrices will mostly cover all of the dimensions which needed to be evaluated by the humans. But the biggest challenge is that most of the human evaluation what people are doing using the Google sheet or the Excel sheets. So we wanted to have some kind of an interactive web application where users just can upload the LLM response and the original ground truth, and do can perform the human evaluation interactively and collaboratively. So we have built this humanly web app. So this is publicly available, and we all just need to upload the two column data, where the column one can have a ground truth and the column two can have the LLM generated response. And using this humanly tool, people can do uh, the evaluate all those matrices in the Likert scale 1 to 5. And at the end, once all the evaluations are done, users can download the evaluated dataset, which can be further used for some other downstream analysis. So this uh, web app is like a very helpful for doing the human evaluation and can help in uh, scaling the human evaluation. But the thing is that when people do the human evaluation, they do consider all those human evaluation matrices as independently. For example, accuracy is considered to be completely independent with the hallucination. Or for example, bias can be treated as independent with the human with the hallucination. But in real world, this is not true. So, for example, if some LLM generated response, they have a very low accuracy, then there is a high chances that the hallucination will be very high. So we just wanted to understand that, like, how can we group all these matrices, and how can we understand the latent cognitive structure of those human evaluation matrices through the data. So we have our our house data set. We call it as a guideline QA data sets. So this is built by our physicians team. So we have a three healthcare guidelines: cardiovascular diseases, colorectal cancer, and diabetes. And based off those three guidelines, clinicians have created 31 question answer data sets. And we also have expert reference answers, which is like considered to be as a ground truth. Then again, to build this data set, uh, we have asked the two state of the art model, GPT-4 and Llama, and generated the LLM response. And then against the true response and the LLM generated response, again we ask the clinician to do the human evaluation using our humanly framework. So the evaluators have done the human evaluation across the 15 human evaluation matrices, and then in the Likert scale 1 to 5. So this give us like a human evaluated responses of 132 samples. So next, on this dataset, we have done the correlation analysis and the community detection to just understand the patterns of all those human evaluation matrices. So we have observed a very interesting patterns. So, and all those data was created while doing the human evaluation independently. But when we did the correlation, we found a very interesting clusters. So for example, if you see the cluster 1 and cluster 2 and cluster 3 and cluster 4, so you can observe that the harm related art matrices, harm related matrices like a hallucination, privacy, toxicity, and bias, they group together. Similarly, the grammar, organization, fluency, these matrices are also grouped together. So this give us a sense that uh, although all those matrices are treated to be independent, but later on when we try to scale the human evaluation, we can group them together, and we never want sometimes we don't need to do the evaluation of all those matrices. We can select few of them and perform the human evaluation, and further we can scale that. Yeah, so we have done a human evaluation in our couple of data sets, and we did some of the research, and then we found that if we have a thousands of samples or 10,000s of samples, then it is very difficult to do the human evaluation for all those samples. So we need some kind of scalable solution to scale this human evaluation process. So for that, solve this problem, we have developed a Gimli tool. This tool is also available through our PIP package. So this tool is basically is a two-phase process where the first process is use the LLM as a judge, where LLMs can judge the other LLMs and on the same human evaluation matrices which are needed to be evaluated for that particular task. And then we can do some subsampling of all those LLM as a judge responses, and only on those subsamples we can further do the human expert review. So it's like we are not doing the human evaluation on the all the samples, but we are selecting some of the samples, and we are doing the subsampling, and we are only doing the human evaluation on the subset of a data set. So this is like a making the humans as a final judge, but also we are doing the human evaluation on the whole data set to get a big the whole picture of the models. So LLM as a judge is like a very common approach nowadays. People are using this very frequently to evaluating the models. So in this approach, LLMs are considered to as a another as a person who have a capability to doing the evaluation of the large language models. So first, we use the similar guideline QA dataset to see the accuracy of LLM as a judge, and how LLM as a judge are similar to the real human or real experts. So we use the zero shot prompt, and we have generated the LLM as a judge responses, and then we have framed our prompt, and we have put all the human evaluation matrices and asked the judge model to rate the responses in the Likert scale value, very similar to as we have done in the humanly uh, or and we only need to we have provided the reference text and the corresponding generated text from the models. So this result is about the how closely LLMs as a judge uh, correlated with the human's response. So we have three GPT-4 DeepSeek Chat and GPT-4o3 judge models, and we also had a ground truth from the humans. So then we did the inter-rater reliability test, and to check how closely judges are related to the humans, and we found some very good and interesting patterns on that. So we found that for the harm related matrices, the judges are very highly correlated with the humans. But for some of the matrices like retrieval, key points, and missingness, we found very low judges reliability on these matrices. This basically give us some sense that although LLMs as a judges are good for some matrices, but for the entire range of the human evaluation matrices, they do not perform equally. So this basically motivate us to do one to go one step ahead and do the evaluation again. So next, the question was that should we do the LLM as a judge check on the all the samples, or we should do uh, subsampling and select some samples to do the human in the loop evaluation. So we tried two approaches. One is the random sampling, which is very common and very simple, and another is we try to do some strategic sampling, because our goal was to select those sample who have a very poor performance by the LLM as a judge, so that we can understand that the the samples which have a poorest performance, what they are doing the wrong. So then we try to assess whether the random sampling versus the strategic sampling, which sampling strategy is good. So for the staging sampling, we use the anomaly detection algorithm, and for the random sampling, we have selected random samples from 10% to 80%. So this bar plot is with the inter-rater reliability between the anomaly based detection sampling versus the random sampling. So we found that the when we select the random sample, there is always a inter-rater reliability with the humans in the most of the matrices are high compared to when we do the strategic sampling. This give us a sense that sometimes random samples are selection for not are not good. We should do some strategic sampling to do the human in the loop and to further evaluate the LLM as a judges. So our next task to assess the LLM as a judge by theory of mind. So we did grouped all those our human evaluation matrices into 5 theory of mind ability groups. So one is the belief and knowledge, where we put the accuracy, comprehension, key points, hallucination, and retrieval. The other is reasoning and problem solving, where we put some of these matrices like reasoning, helpful, and organization. Another is communication and language skills, where we put fluency, missingness, and grammar. Another theory of mind ability is emotional and social intelligence, where we put the biasness, toxicity, and privacy. And the fifth group was the self awareness and the metacognition, and where we put the humanly matrix. So, based on these theory of mind abilities, we assess the LLM as a judge, and we found that uh, again for the harm matrices, the theory of mind ability has good, but for some other um, theory of mind abilities, LLM as a judge are not doing a very good job. Yeah, so this overall gave us like some sense that although the human evaluation is gold standard, but scaling is difficult. So then we need some scalable solutions. So for that, we build the Gamely, and we have published this Gamely as a pip package in a Python. So it can be installed just by the pip install command, and and then using that after installation, people can do the LLM as a judge, where input can be only two information. One is the reference information, another is the model generated information. Then users can put the model as their choice with the API key of the model, and in just one line of code model, users can generate the LLM as a judge responses. So overall, conclusion for both those tool is that our task is to set some interactive way and scalable way to doing the human evaluation. So first we build the humanly, where users can interactively do the human evaluation, and the second tool is the Gamely, where uh, by using Gamely, users can scale their human evaluation by setting their LLM as a judge model, and then again further subsampling the LLM as a judge response and doing human in the loop to make the humans as a final judge. So these are the few studies related to all our work. So for humanly, we have a separate paper published in PJ Health System, and for the gamely, we have published a paper in ACM BCB conference, and the theory of mind evaluation of LLM as a judge, we have published a paper in AAAI theory of mind workshop. I think with this, I would like to complete my presentation.
Awesome. Thank you, Raghav. That was great summarization. Again, few different methods that we were using this year to essentially address the same key question uh, that uh, that Suhana and many others have been trying to. But I think we started from the same point. We started from the same point, as in these evaluations are not robust enough, and we need to do a better job at it. So I think we learned a lot through this year from each other's work, and hopefully we will continue to learn more and create better evaluation tools as we do this, those uh, which are more robust, those which are scalable, and those that can be adopted in near real time for this work. uh, Let me just share my screen here. Just give me one moment. Well, I want to go back to Suhana and get her thoughts on this. There was this one paper, I had put it in the chat too, which is the leaderboard illusion. And we have seen a lot of leaderboards come up. There was this one benchmark that also was published by Google. I think it just came yesterday or day before, and I was trying to read through that. And it was interesting how they described the performance of some of these models. And one of the questions that I'm wondering is beyond the metrics. Clearly, there was a gap in how we were evaluating based on the metrics before. Everybody was doing different Likert scales and other things too. But also, a lot is based on what data set you're measuring them on, what data set you're evaluating them on. And as we experimented before, we found that there is a variability even amongst the data sets for the same task. So you might be trying to measure it for a given task. Maybe it's administrative, maybe it's for clinical decision support task or documentation task, summarization task. But for the same task, if there are two different data sets, all of a sudden you find that these model behaviors might be different based on the underlying data set. So, how do we overcome that? Because if we are going to have the ground truth, the type of ground truth impact the results, then you're not really getting the true measurement. There's still a lot of variability there. So, what's your impression of these leaderboards having done this? What are some of the key takeaways you would say?
Yeah, so task-based evaluation again is really big and everyone's doing it now. But as you mentioned, even within tasks, there's heterogeneity across
Yeah.
data sets. With MedHelm 2, when we released it, we said for administration, this is clearly on Stanford data. Maybe this breaks for Mayo, or maybe this breaks for Boston Children's. So really the way to go forward is similar to what I said about live deployments, because at the end of the day, distribution shifts have always been prevalent and always occur in the field. And one way to overcome them is to start measuring your model performance on the data that's closest to your distribution, closest to your setting. So we actually also have some people, some actually healthcare systems wanting to use MedHelm to create their own private data sets. They don't release them, but that's for them to sanity check. All right, on my distribution, on my type of data for this specific task, how well do these models do? So really going forward, it is, of course, a community effort, which will probably give you a good estimate towards how well a model can or can't do. But towards the end, when we talk about questions around personalization and specificity to a certain domain, to a certain setting, um, we have to develop our own data that's closest to our distribution.
Yeah, that's a great point. I think still learning a lot from all this, right? These leaderboards themselves are evolving is one thing that I feel. Raghav, you showed the different aspects of LLM as a judge, and is LLM as a judge robust enough for us to trust and depend upon that with so much variability amongst the LLM performances? As I said, like that paper, and I'll put it in the chat. It was really surprising. The best performance was somewhere around 70% or so. And that's with some of the so-called reasoning models these days. So then we are asking them to be the judge and the jury. Uh, we have to have expert in the loop, but expert in the loop is not a scalable solution. It's not an efficient solution either. So, what were some of the key learnings from that? I think there were some questions and comments in the chat about it too.
Yeah, I think this is ongoing research. So in for like our research, we didn't find LLM as a judge is a kind of a replacement of the humans, and even and also LLM as a judge don't show a very good performance. For some matrices they have performed well, but for some matrices they didn't perform well. So I don't think LLM as a judge is going to be, and also we didn't try other like a prompting approaches. We just use the zero shot prompt. We didn't try the few shot learning or other fine tuning. So I think in the zero shot setting, LLM as a judge are not well enough. But if, for example, if we build a separate model for LLM as a judge, for example, if we can fine tune the LLMs for doing the LLM as a judge, then they can be better. But in the current setup, they're not like a really very good.
But then, if you have to fine tune them for each task or for each scenarios, then that again becomes as challenging as having human experts or finding the human experts to do it.
Yeah. Then like the next stage would be to like the helping humans to help using the LLMs, like not first do the generate the out, like the first doing the evaluation for all the data sets. So we have to put some solution where evaluators can take the help of LLMs at every step of evaluation. When they have like any questions or any doubts, they can ask the LLMs, so that they can be more efficient, rather than just using the LLM as a judge as a completely independent solution. So we have to put something in loop when evaluators are doing the evaluation, not after the evaluation are done. So
Suhana, following that, so we're talking about like some of the things that have been tried recently with chain of thoughts or reasoning and so-called reasoning models these days, claiming to be superior and being able to reason. uh, Again, your work was very illustrative that there is some amount of psychophancy with these models too. There has been some related research done, or that they're not going to say no generally. And we did some adversarial questions when we were testing in some of these models too. And we tried to trick the model asking non-human related questions like, I'm a horse, should I take aspirin or not? It was very interesting to see how they would respond. Some of the models will give you an answer, and some of them would say like, "Well, this is not right." Is it truly reasoning? Are we really there reasoning level, or are we? What's your sense of? Are we still at a regurgitation or being able to articulate where these models are articulating some responses very well?
Yeah, I think so. I think there was a time, there was a phase when reasoning models came out where we thought that since it's a different type of reinforcement learning, they're this, thinking chains that sort of mimic how we as humans think. So they would probably have some more restraint when we're asking questions that clearly shouldn't be answered, right? And it seems like, again, through the paper that I presented, And we also have some follow-up work to sort of see when do models restrain and what's the rate versus when do they just blatantly answer even when they shouldn't. Um, I think moving forward, there seems to be a poor correlation between the reasoning capability and the restraint. So that's why I think the field is now moving more towards, all right, we're not going to rely on the model to restrain when a certain question is asked. Rather, we were going to impose a layer of guardrails where based on certain types of questions, no matter what response the model gives, we're just going to block that and maybe show a blank or not applicable or something to the user. And at Stanford, as we're live testing our chatty HR tool, we're actively thinking because there are clearly some questions clinicians are asking where we don't even have the data to answer them. And of course, when we don't have the data to answer them, the model is going to hallucinate, but we don't want the model to be giving hallucinated content to clinicians. So can we put on these guardrails that just stop responses altogether and enable adoption in a more responsible way?
Let me also ask you a slightly different questions. Do you think there is a concern that with these models, are we just unearthing biases or are we accentuating and perpetuating biases?
Yeah, I think that's a big reflection of the training data. For a while, like even one of the earliest papers that came out around biases in healthcare was out of Roxana Danish-Jew's group. And there they were clearly showing that, models are perpetuating what they've learned in the training data. Again, things have gotten better. Of course, there's work out of Google on bias correction, but then there are also horror stories about bias overcorrection. So I think bias in itself is always going to stay because it's a property of the training data. And unfortunately, the training data that we have spanning so many years has biased content. So it's really hard to handpick out like the unbiased measures. So that is something that we have to assume that the models are going to have. Even recently, I remember there was a paper or a commentary where they were just changing the patient demographics and asking the same question. In some cases, the answer does change, but in some cases, it shouldn't change, but the model still answers differently. So that's something that clinicians or as users, we have to be careful of, we have to be aware of.
Raghav, I have a question for you. So, doing some of these word-based evaluations is still simpler. I scratch my head when we are talking about multimodal agents, and you have image and you have text and voice, and now there are voice agents all together. And how will we wrap our head around it? Because that everybody's talking about AGI, and how do we measure AGI then? You're on mute.
Yeah, I think it's going to be more difficult as multimodal will come out. So I think although these evaluation evaluates the model performance, so the in future I think because of lots of third party LLMs are going to be used heavily. So not just we will be not focused only on just the model performance evaluation. We will be mostly focused on which model is more cost efficient, which model is like a less expensive. So these kind of factors will come, and these might will become the primary use case of using not just the model performance. So I think that the direction of the evaluation is going to be changed very completely. So in future, when the multimodal and the more model will come out and the cost of the model will be a one factor, then the evaluation is not going to be just the quality of response evaluation. There might be other factors as well.
So another way to frame that, and I think that's what Suhana and her team are already doing. Another way to frame this is like I think the model performance is topping out in some of these models. There's not much to gain in many
Yeah.
ways. There might be certain different subtle variances in their performance for different matrices, But you're saying it's
Yeah.
more about usability studies, feasibility studies, application studies. That is similar to chart EHR, what Suhana reflected upon. They will matter more than anything else. So more real time series. But Suhana, I have a harder question than that for you. What about AI agents? How are we gonna address that one? Because it's not just the output you're measuring, but also we in our research lab we have been working on some of the frameworks for that too. But it's not just the output that you're measuring, but also the process of that output that you're trying to measure in that. So it becomes harder. It's like this is becoming like Olympics sports now.
Yeah, no, it's a great concern, and we all have that. And actually, my next step is we're actively working on expanding MedHelm to incorporate agents. And as you beautifully mentioned, it's not just the outcome metrics, but it's also the process metrics that we care about. And really, I think, and this was heavily reflected at NeurIPS that was happening in the last week or so, that we need to be moving away from, these static benchmarks. And similar to, even I say MedHelm is now outdated because it's just single turn, one Q&A response pair that we're evaluating. No one's probably using models like that anymore. Now people are want full autonomous agents doing different tasks. And the real way to evaluate them is to just throw them in a real world setting. So Chat EHR is one example, but something that we're actively working on is creating live environments for these agents. So one very concrete example that we're hoping to release is for administration. Nothing is a single turn conversation or a single shot task. It's a fragmented workflow with probably 20 steps. Even submitting something as simple as a prior authorization, you're split between three different screens. You might be calling somebody to get some more information, and that entire package, that entire environment needs to be created, and agents need to be tested in that environment live to see how they compare with humans. So, of course, there's this huge trend, huge call for action from big tech as well to generate these real world environments, not only in healthcare, but in other settings too, and throw agents there. Of course, we've seen through some agentic benchmarks, agents don't do that well. So then, once you have these environments, you can then use them to train your agents through some reinforcement learning on improving upon these environments. So you have these agents that can hopefully submit prior auths, or they can do billing for a certain patient record. So really, we're moving towards generating these live environments, um, especially in healthcare, that again can stress test agents and then automatically be used to train them and make them better.
So maybe a, a digital twin solution with agent as a judge in many ways. It sounds like metaverse to me. Uh,
It is, yeah.
Raghav, where are we going with this next year?
Uh, I think because agentic AI is still new, many people have not explored yet. So next year will be more on the agentic AI before like saying that agentic AI is not going to work on anything else. So there is going to be a lot of research on agentic AI in next years.
Suhana, gonna give you the last word.
Yeah, I totally agree with Raghav. Agentic AI is probably going to be the new frontier where everyone is headed. But hey, like these things move too fast. Where we're talking about it now, and 2 months from now, it's completely tossed, and there's something new. But I'm still very bullish on the idea of models will change, architectures will change,
Yeah.
but evaluation is something that is always going to be very important. And there are way too many papers out there saying that the verification gap is real. Generation has become trivial. It's the verification that's actually the bottleneck. So, again, to all the people in the audience, to all of us, more power to you to continue working on evaluations, strengthening them. to really stress test these models, agents, or whatever's coming next.
Yeah, a great call there, Suhana, and that's what I've been advocating to. That we might take different approaches, but I think we have similar philosophies, just like Avnish in the audience is saying, and I think we have to do this, especially for healthcare, in a more robust way. We have to lead this, and a great opportunity for all the clinicians. I saw like some great comments in the chat too about different approaches, something to think about. Again, very famous saying like trust but verify. That's what we need to do with this. And recently took the course on agentic AI from Professor Andrew Ang, of course from Stanford University, and in that course also he said like the differentiator between those who will be successful in deployment of agentic AI versus those who don't do it as robustly is evaluation. That's going to be the underpinning of success. It's not about how fast or how cool you make it, but it's whose evaluation is robust so that it stands the test of time. Because what we want to prevent is anything similar to the AI winter that we had in the past. So it has to be robust so it doesn't fall apart for us. Well, thank you so much. This was a very exciting session. I hope everybody learned a lot from this. I did for sure, and that is our year-ending session for 2025. We will be back in the new year in 2026. Hopefully, we will have Suhana back. Hopefully, we will have many of you back to talk about your exciting work, and we can learn from each other. In the meantime, happy holidays, and see you in the new year. Thank you so much, everyone, for joining us.